In number 21, what can happen is that this club's going to invest $10,000 to host this baseball game, and they expect to sell tickets worth $15,000. Now, if it rains, they don't sell any tickets, and they lose all their money. But if it does not rain, then they'll make what? They're going to invest $10,000 and sell tickets worth $15,000, so they'll make $5,000. So what we want to do is find the expected value. If the weather forecast for the day is 20% possibility of rain, is this a good investment? Let's get the expected value. Let's write down what we've got here. I like to do it in a table. Let's say here's the outcome. Here's the probability of that outcome. And then here is the value. So what could happen? Well, it could rain, and the probability of raining is 0.2, right? 20%, right here, 20% chance of rain. And the value then would be negative 10,000, right? We're going to lose $10,000 if it rains. Now, another outcome is that it does not rain, and the probability of not raining is 80%, and the value here is going to be, now, we're going to sell $15,000 worth of tickets, but it's going to cost us $10,000 to do that, right? We're going to invest $10,000 and hopefully sell $15,000. So our value here is going to be $5,000. Right? So if it rains, we're going to lose $10,000, and if it does not rain, we're going to make $5,000. So the expected value, let's write this. The expected value is, this is going to be the sum of x times p of x. So this is going to be, now, x and p of x. Here's x, here's p of x. So this is going to be negative 10,000 times 0.20 plus 5,000 times 0.80. And when I did that, my calculator tells me I'm getting $2,000. So, since the 2,000 is positive, right, that's a positive number, this is a good investment, right? That's what we're trying to do is this a good investment? Because it's a positive expected value, we'd say it is a good investment. But here's the meaning of this $2,000. If we were to do this over and over and over, right, this being selling these tickets, if we were to do this over and over and over again, thousands of times, sometimes it would rain and we'd lose our 10,000. Sometimes, most of the time, it will not rain and we will make 5,000. So in the long run, when we average it out, every time we run this game, we would win, on the average, $2,000. Now here in problem number 22, we're already given a table. Here's the values, and here's the corresponding probabilities, and what we want to do is get the expected value, but we know the expected value, we have a formula for that, right? We wrote it right down here. The expected value, matter of fact, I'm going to write it up here. I'm going to say this. I'll write it here. The expected value of x, let's write it like that, E for expected value of x, the expected value of that x is the summation of those x's times p of x's. So what we need to look at is this. Let's get these products, x, p of x, right? It's x and p of x, x and p of x, and then we'll just add them all up. Let's put another column on here. How about x, p of x? And what we're looking at then is this is going to be 1 times 0.27. This is going to be 2 times 0.31. This is 3 times 0.18. This is 4 times 0.09. And this is 5 times 0.15. So on my calculator, I just did this. I just typed in 1 times 0.27 plus 2 times 0.31 plus 3 times 0.18 plus 4 times 0.09 plus 5 times 0.15, and that gave me this number right here, the 2.54. So that comes out to 2.54. So what we're saying here is this, that the expected value of x is 2.54. Now what this means is this, x is the number of times a buyer investigates a product before buying it. So if we took a whole bunch of buyers, hundreds of buyers, on the average, they would investigate the product 2.54 times. Now, of course, some people are going to investigate it only once, some twice, some 3 times, 4 and 5, but on the average, that would be a 2.54.